Good afternoon to everyone. Our topic
Good
is
afternoon, sir.
autocorrelation. Today we will discuss about autocorrelation. Then what is meant by autocorrelation and how we can identify the autocorrelation. Also, we will discuss if the time permits. So basically, we learned about what is the regression. Why we can study the autocorrelation means when you are doing the regression analysis, we will get some problems. Okay, so that is what are the problems we are getting in the regression analysis only. So there is one of the problem which we will get in regression analysis. So that is the case only. We need to study the autocorrelation. Then we will study that what is mean by autocorrelation and other things also. So for the introduction part, we need to understand first. So what is in by autocorrelation? See, yeah, the autocorrelation means the errors are auto correlated each other is called autocorrelation. Simple autocorrelation is nothing but the errors are correlated. Errors are nothing but what are the errors are there in regression analysis. So if the errors are correlated each other, that is called autocorrelation. For example, when you run the regression analysis, you will get some errors. That is y is equal to a plus b1 x1 plus et or ei. So if you take into account ei, that is a error. So if error is related with the another error in the particular series, so it is called autocorrelation. The autocorrelation is also called serial correlation. See, there is autocorrelation is also called serial correlation, or sometimes they will ask that autocorrelation is also known as serial correlation. Serial correlation. Then serial correlation means what is, sometimes they will ask the what is meant by serial correlation. So it means that lag correlation between the two different series. Nothing but here lag correlation, nothing but the present year error term is correlated with the its preceding error term or its succeeding or successive error term. That is called lag. Okay. So if it is present year error is correlate with the its previous year error, that is called lag. Lag is 1 year. For example, present year or last year, so the lag is 1 year. So here the present year is error, present year error is correlated with the its preceding year or successive error. It is called auto correlation. In serial correlation is same. It means the lag correlation between the two different series. Then next one. Then shortcut I have written that AC nothing but autocorrelation. So it is a special case of correlation. See, so when we have studied in the correlation in the second semester and first semester also, we have studied about the correlation. So the correlation is meaning is same. Yeah, autocorrelation also same, but autocorrelation is related with the error terms. The correlation is related with the variables. So variable is nothing but one variable and another variable. So autocorrelation is a special case of correlation. It refers that relationship not between the two or more variables. See, the autocorrelation relationship between the variables, that is the present year and previous years errors. But here the autocorrelation is not between the two and more variables, but between the successive values of the same variable. Same variable in the sense only one variable. For example, present year depends on its previous year. Okay, so that is called, it is a relation between the variables that have the successive values of the same variable. Nothing but error term is related with its error term only. That is a auto correlation. That is different from the correlation. Okay. Simple, if you take into account the in the regression model, we can write yt is equal to beta 1 plus beta 2 x2 t and ut. Nothing, why I put here t, there is a time series. Okay, for the times when you use the time series data, you need to write this type of equation or model. So yt is equal to beta 1 beta 2 beta 2 t plus ut. Here y is nothing but dependent variable. So beta 1 is nothing but intercept or constant. Beta 2 is nothing but coefficient of x2 variable in particular time series, time in the time. Then u is nothing but error term. We can say random term, stochastic term, or disturbance term also we will call. Okay. Then if you take into account yt is equal to beta 1 plus beta 2 x2t plus ut minus 1. See, this is a present year error term. Then this is a last year error term. Ut minus 1. Ut minus 1 nothing but this is a present year. T minus 1 nothing but 2020 minus 1 2019. So last year error and present year error. Then if you take another example, yt is equal beta 1 plus beta 2 x2t plus ut minus 2. Okay. See, this is error term. Present year error term is if it is related with the this, if it is relation between the this ut minus 1, it is called autocorrelation. Present year error is correlated with the its successive values of the same variable in the sense error term only. See, the error, this error is correlated with another error term, whether it is ut minus 1 or ut minus 2, ut minus 2. Okay. So if the error terms are correlated with each other, it is called autocorrelation. Autocorrelation. Clear? Nothing but, see, this is a present year error which is related with the which is correlated with the its preceding error term. See, for example, if you take into account any example, for example, see, if you do some mistake today, so today mistake may be depends on last day mistake. See, so that is some relation between the, for example, if you take into account at what time you are going to come to a particular class, for example. So if you do some mistake today, so today mistake it may be depends on previous. For example, in the previous day also, if you attend some nothing but if you are joined late also, so that gap and today how much you have at what time you joined. So that is a different, that is a error. If you want to join at particular 9 o'clock time only, but you might have joined at 9:05, for example. So today you might have joined at 9:03, for example. See, there is a 2 minutes difference. That is today whatever you have done some mistake, it is depends on previous day. So that is called auto correlation. So generally in our econometrics, see the autocorrelation is one of the assumptions of CLRM. What is CLRM? Classical linear regression model. So there we have studied about assumptions of CLRM. That is the assumptions of classical linear regression model. In the first module only we have learned about. So within the assumptions of classical linear regression model, we have that no autocorrelation. So we have studied. So that is we can write in the economic terminal. There is a expected ui comma uj is equal to 0. What it means ui and uj in terminology in the econometrics? Ui nothing but a particular error term ui. In we can say cross section data we can write ui instead of ut. Okay. So ui comma uj is equal to 0 nothing but there is no relationship between the present year error term and its successive values of error terms is equal to 0 nothing but, so there is no relationship between the two variables, nothing but present year error and its previous year error term, that is 0. It means that if there is a correlation value is equal to 0, we can say that there is no correlation between the particular variables. So in the economic terminology we can write expected ui comma uj is equal to 0. It means that expected, whatever we expect, for example, if you expect there is a relationship between the two error terms, if you calculate it, if it is 0, you can say that there is no autocorrelation problem. If expected uij is not equal to 0, for example, if see, but when expected ui and uj is not equal to 0, this condition is also known as autocorrelation. It means that if there is any correlation between these two, we can say that autocorrelation. Okay. Expected ui and uj is not equal to 0. This condition is also known as the autocorrelation. So in your set and net exams, probably they will ask that. So if expected ui and uj is equal to 0, what it calls? If expected ui and uj is not equal to 0, what it calls? You can remember. Okay. Then the correlation between the errors observed in the time series data and cross-section data. For example, as I told you that, so when you observe the autocorrelation, so you can find out the autocorrelation problem in the both series data. See, if you use a time series data also, you can get some autocorrelation problem. But if you take into account cross-section data, you may get autocorrelation problem. But when you compare with the time series and cross-section data, you will get a more problem in the time series data. So you may get less problem when you use cross-section data. Okay. So that is we can find out the correlation between the errors observed in time series as well as cross-section data. We can remember. So as you know that what is meant by time series data and what is meant by cross-section data also. So here, if by chance a correlation is observed in cross-section data, for example, as I told you that, so there is a little chance, nothing but there is a less chance to get autocorrelation problem in cross-section data. For example, cross-section data is nothing but if you collect information from the respondent directly. Okay, so you may get less chance to get autocorrelation problem. For example, if you get, that is a, if by chance, if there is a autocorrelation problem in your data, in your regression analysis, it is called spatial autocorrelation. Spatial autocorrelation. For example, if you find out a autocorrelation problem in a cross-section data, it is called spatial autocorrelation. Spatial autocorrelation. Please remember this point. So that is expected UI is equal to 0. For example, sometimes they will ask that. So covariance of U and Uj is 0. Sometimes they will ask covariance is nothing but what is covariance? Simple, the correlation between the U and Uj is 0. That is called no autocorrelation. Sometimes they will use the terminology they will use when they will ask the questions in the different exams also. The covariance of U and Uj is equal to 0. That is called no autocorrelation. If there is a covariance between U and Uj is not equal to 0, it is autocorrelation. See, what is covariance? As you studied in the previous semesters, the covariance is a measure of joint variability of two random variables. Random variables in the sense here in the I and j, nothing but so error term and its successive error terms I and j. So as we noted that autocorrelation is existing time series data. So as I told you that, so you can find a large number of nothing but you can get a more problem, that is the autocorrelation problem in time series data. So I can give you example, that is example is stock prices. See, today stock prices is depends on previous day stock prices. For example, at today 3 o'clock stock price is depends on at today 2 p.m. stock prices. The 2 p.m. stock prices depends on its at 1 o'clock stock price. So in the economics generally, when you take into account the time series data, so today, for example, if you take in agriculture also, see, so if you take into account paddy production in particular 2020. So in the paddy production 2020, it depends on last day production also. Clear? See, in the case the stock prices, the today's stock price depends on the last day stock prices. So in that case only, we will get a autocorrelation problem. For example, if you take into account the possibility of strong correlation between the stock in time t nothing but in the time series with the shock in time place t plus 1. For example, today's stock prices may affect on tomorrow also. For example, today's stock price can affect on the tomorrow stock price. There is a t plus 1, nothing but I can add. Nothing but today's stock price is tomorrow's stock price depends on today. So in the stock market, we have studied about Sensex, Nifty also. See, the Sensex and Nifty depend upon the previous prices along with the market decision. See, for example, if you take into account when you see if somebody is win in the election, see simple the stock prices Sensex index, we can say that sensitive index and Nifty. So in the general in newspapers and in the news channels, live channels, they will telecast that. So there is a Sensex has been increased from some point to some point. So due to some win in the particular party in some particular location, particular area also, they will explain. So regarding that, the Sensex and the Nifty depends on the previous prices along with the market decisions. For example, if RBI is going to announce a interest rates, for example, if you take into account some repo rate and repo reports, SLR and some other rates, if they will going to announce today. So the stock price depends on the market decision. See, in the what are the market decisions going on in the markets? So automatically that decisions can affect on the stock prices. For example, if the policy is going to announce today, so the policy may affect on the stock prices. So that is the case. The previous stock prices, nothing but today's stock price depends on the previous stock prices along with the market decisions. Market decision, the policy maker, some repo rates, some other rates, if the government is going to announce. And in the industry, if you take into account,
Sir,
yes, please.
Sir, Sensex ki Nifty ki difference in sir.
So the Sensex nothing but it is the index of BSE. Nifty is the index of stock price, NSE, National Stock Exchange. So Sensex is called a major 30% share of BSE. That is called sensitive index. Nifty is nothing but a 50% share in the National Stock Exchange. That is called Nifty. So Sensex is related with the BSE. Nifty is related with the NSE, National Stock Exchange. That is the difference. Okay, is it clear? Am I clear?
Okay, sir. Thank you,
Yes,
sir.
sir. Yes, sir. Thank you.
So if you take into account in the industry, the strikes in 1 month can affect on output. For example, if you take into account, if the laborers, those who are working in the industry sector, if they want to fight for that their salaries, their wages, if they will go for that strikes, for example. So if you take into account the strikes in 1 month can affect on output. For example, if they will do a strike in particular 1 month, the output may be affected. Nothing but this strike is effect on the output generally. So we cannot believe that the last month strike may not affect the next month. For example, if you take into account, I have given an example also. See, output in January 15 units. For example, in particular industry, they will produce particular labors. They produce 15 units in particular month. So they want to do some strikes in order to get more wages. So during the February month, they have gone for the strike. So if they are gone for the strike, the output may be 0, right? So then, see, after discussion with some industrial person, so the strike is over. So immediately they can they enter into nothing but they have done job. They have entered into the March month. So they produced 50 units or more or less 50. But the company will they believe that the last month strike may not affect on the next month. See, for example, if you take into account today, if you take some leisure period, it may affect on tomorrow also. For example, see, so if you take into account your wake up time, for example, if you break some time in a particular day, so today, if you break the particular time, it may affect on tomorrow. Generally, if you, for example, if your wake up time is 5 o'clock at morning, so if you break one day, for example, in the particular Monday, if you take into account, in the Monday, if you wake up around 7 o'clock, so tomorrow you may not wake up at 5 o'clock. You may wake up below 5 o'clock, nothing but before 5 o'clock or after 5 o'clock. There is a chance, there is a probability is there, right? So that is why that this thing we cannot believe that last month strike may not affect on the next month of output. So that's why I put it the March output 50 or more or less 50 or more, maybe more than 50 or less than 50 years. Nothing but sometimes this strike may affect on the next output also. So then if you take into account regression models, when you are using in regression model, see generally we can write like this, that is the regression model, the multiple regression. So yt is equal to beta 1 plus beta 2 x2 t plus beta 3 x3 t plus ut. This is a multiple regression. So for example, in order to write in our examination, see what is autocorrelation, no autocorrelation. How do you define in autocorrelation? Simple, here t, there is a terra term. So if you take into account, right, if you yt is equal to beta 1 plus beta 2 x2 t plus beta 3 x2 t ut minus 1. So if you write like this, ut and ut minus 1, if there is no autocorrelation, if there is no correlation, you may write no autocorrelation. Or else you may write no autocorrelation, that is a covariance of u and uj, or expected u and uj is equal to 0. As I told you that there is a no autocorrelation. If you find autocorrelation, you need to write the covariance u and uj is not equal to 0. So it means that the autocorrelation is there, but we cannot say there is a negative and positive. But if it is not equal to 0, it may be negative, it may be positive. Okay, then we will come to know what is negative autocorrelation and what is positive autocorrelation. So sometimes we will write also autocorrelation ii is not equal to 0. In general, we will write, as I told you, that expected ut and ut, yes, nothing in time series we can write. So as I told you, u and uj we can write in cross section data. So if you use the time series data, expected ut and ut minus s is not equal to 0. That is a autocorrelation problem, right? So please keep in mind u and uj is nothing but we can use u and uj for the cross section data. When you use ut and ut minus s, it is for time series data. Please remember. Then, so how we can write autocorrelation? See, as I told you that today error is depends on the previous error. Nothing but whatever you have done some mistake today, it mistake is depends on previous. Nothing but as I told you that if there is a correlation between present error term is correlated with the preceding error term. So we can write autocorrelation, that is error term epsilon et is equal, this is not p, this we can call it rho, epsilon et minus 1 plus vt not et. See here, this is a present error term, is depends on its previous error term. Nothing but if something is happened in the last day, it may affect on the today. Okay, that's why it is epsilon t is equal rho epsilon et minus 1 plus vt. So rho, it is called rho, that is called coefficient of previous error term. Rho is equal nothing but rho is equal, that is a, it seems like p but not p. So rho rho we can call rho rho. See here the rho is nothing but the coefficient of previous year error term. Nothing but if you take into account beta 1, beta 2 is nothing but coefficient of x2 and x2 1. So like that, so rho is nothing but coefficient of previous error term. What is v here? So when you use error term here, if you take into account the random, that vt is nothing but random error term, random error term. So as I told you that, so today's stock price is depends on previous year stock price. Random is nothing but market conditions or market decisions. Vt is nothing but random. So for example, if you take into account present year error term is depends on its previous error term, it is called, this is known as the first order autoregressive relationship or first order autoregressive. Sometimes, for example, if you take into present year error term is depends on its before previous year error term, nothing but epsilon et rho epsilon et minus 1 plus epsilon 1 et minus 2 plus vt. For example, if you write another equation, that is called second order autoregressive. Nothing but present error depends on 2018 error. Nothing but as a first order, nothing but present year 2020 error is depends on 2019 error. It is called first order. So 2020 error is depends on 2018 also. It is called second order. So am I clear, dear students? Hello.
Yes, sir.
Yes, sir.
Thank you. See, as I told you that error depends upon the its past error, nothing but its previous error value, and present random variable. Present random, nothing but you can say, you can error is nothing but here, whatever the error is there. Okay, error is depends on its previous error and market. You can say present random variable, nothing but market condition or market decision. You can say. So as I told you that whereas the epsilon is nothing but error term, p is nothing but it is not a p, that is its symbol is rho, that is called rho rho, that is a coefficient of previous error term. Vt is nothing but random error term. Okay, see the coefficient of rho is called first order autocorrelation coefficient. As I told you that that is a rho is nothing but coefficient of previous error term. Okay, so that is, it is also called coefficient of rho is called first order autocorrelation coefficient. As I told you, the first order autocorrelation coefficient value. So how much the rho value will come? The rho value lies between -1 to +1. Symbol you can remember. Rho value lies between -1 to +1. That is called, as I told you that the rho value takes value from -1 to +1. The rho value always get -1 to +1. So we need to understand if rho is equal to -1, what it is. If rho is equal to +1, what it is. If rho is equal to 0, what it is. We can easily understand. See the next slide. So for example, if it is obvious see that the size of the rho will be determine the strength and serial correlation. So generally on the base of the this rho value, so the rho value can determine that the strength of the serial correlation. So is depends on the rho value. We can say that how much the correlation is there between the two error terms, whether it's strong or weak or no. See, generally we have the three different cases. See, the first one, if rho is equal to 0, what it means? Nothing but the coefficient of previous error term is 0. It means that there is no dependence on nothing but present error is not depends on previous error. That is called no autocorrelation. No autocorrelation. Then if rho is equal to +1, nothing but if the coefficient of previous error term is equal to 1 or nearly 1, we can say that positive and strong autocorrelation. Positive and strong correlation. If rho is equal to -1, we can say that there is a negative autocorrelation. Nothing but negative and strong autocorrelation. If the rho is equal near to 1, nothing but which is near to nothing but 0.8 and 0.9, we can say that a strong autocorrelation. If the rho is equal to minus 0.8, 0.9 or 0.75 above, so we can say that there is a strong negative autocorrelation also we can say. So as we study the correlation, same thing it will be applied for the autocorrelation, but there is a r is equal to 0 here, rho is equal to 1, rho is equal to 0, rho is equal to 1 and rho is equal to -1, and rho is equal to near to 1 or near to -1. For example, as I told you that if the rho approaches unity, nothing but which is approaching unity, nothing but equal to 1, so the value of previous observation the error becomes more important in determining the value of current error, and therefore high degree of autocorrelation exists. Nothing but high degree, nothing but positive and high or strong autocorrelation exists between the present error and its previous error term. So as I told you that if rho is approach -1, we have a high degree of negative autocorrelation. If it is very close to -1, nothing but -0.8 and 0.9, which is very near to the 1, -1, so we can say that there is a high degree of negative autocorrelation. So there is a one question that as we listening, so as we are listening, so you may have some doubt. Why does autocorrelation occurs? Why the autocorrelation problem occurs? That is the main question arise in particular autocorrelation problem. See, as we have studied, there are several reasons, some of which as follows. For example, see, so there are several reasons to get autocorrelation problem in regression analysis. So there are many reasons to come autocorrelation problem, but we have discussed very important points which we will discuss. The first one is a inertia, okay, or fluctuations. Inertia or fluctuations. Second one, omitted explanatory variables. Omitted explanatory variables from the model. So first point is nothing but see, that is a inertia or fluctuation. For example, if you take into account any data, if the data is fluctuating, so generally that is called inertia. So omitted explanatory variable, nothing but if you are deleting some variable from the model, that is nothing but if you are taking some independent variables, if you remove from the model, you will get autocorrelation problem. Then third point also, misspecification of mathematical models. Misspecification of mathematical model. For example, so if you misspecified your model, you will get autocorrelation problem. For example, if you take into account when you are using a formula or mathematical model, if it is right only, you will get no autocorrelation problem. If the model is not correct, you may get autocorrelation problem. But when you do some misspecification of mathematical model, you will get autocorrelation problem. Then another one, incorrect function form. Incorrect function form. So when you're modeling, when you're doing some functions, so it should be correct function form. If you do some incorrect form, incorrect formation of functions, you will get autocorrelation problem. Then if the data is curve wave phenomenon, so as we have studied as economic students, that what is meant by curve wave phenomenon or curve wave. So if you take into account like this, that is called curve wave phenomenon. Nothing but see, if you take present year, it depends on previous year depends on another previous year depends on another previous. Okay, so that is called curve wave phenomenon. Then lags variable. For example, if you use lag variables in your model, in your analysis, in the regression analysis, you will get a autocorrelation problem. Then if you do some manipulation of data, for example, if the data is not available in particular data periods, So if you do some manipulations, you will get autocorrelation problem. So that is the one thing. The another one, data transformation. For example, in order to your data, for example, if you take into account any data, so in order to maintain a uniformity in the data set, if the data is set, if your data is transformed into different categories, you may get autocorrelation problem also. Sometimes if you convert the data, if you convert your data into the logarithms or natural logarithms, sometimes instead of using observed data, you may use log values data or natural logarithm values. You may get autocorrelation problem. Sometimes if you're not using that, if you're not transferring the data also, you may get autocorrelation problem also. So you need to take some careful observations when you're doing the multiple regression. See, there are 8 main problems which can have a reason to get a autocorrelation problem. These are the 8 major problems. First one is a inertia, omitted explanatory variable, misspecification of mathematical model, incorrect function form, Kappa wave phenomenon, lags variable, manipulation of data, and data transformation. Okay. So thank you everyone. Tomorrow, next class, we will discuss about deep analysis of what are the reasons or what are the causes of autocorrelation. What are the causes of autocorrelation in regression analysis?